annuities are the best. I mean, I'm not really sure I believe that, but I'm sure there's stuff better than annuities, but I'm trying to keep myself entertained here. So want to take a look at a couple more examples here. So I'm going to have to break format in the notes file a bit, just as a heads up. There's an example that talks about how you can use Excel to do this. You can, and we're going to look at it, but that happens quite a few times, and it's more efficient in terms of recording if I just do all of the Excel content in one video instead of having like 4 different 3-minute videos, because I can't manage to mesh this with an Excel screen. Sorry. I promise we'll get there. Anyway, so there's another problem talking about somebody named Kate and trying to save up money. We'll get back to Kate in a bit. You'll see why when we actually try to analyze Kate's situation. I want to jump to the next page of the notes handout and look at the next couple of examples, because it turns out they have something in common, and that works well in terms of video theming. I'm starting to think like a YouTuber. This is weird. Anyway, so what I want to look at here, we got a family who's trying to put away some money so they can make a down payment on a house. All right, they want $40,000 set aside in 3 years. So here's the catch. This time around, we don't know how much they're paying. That's what they're trying to figure out. How much do they need to put away into this annuity? So we know instead that they want a future value of 40 grand. So that's our S this time around, and we got to find R. So given the rest of the information here, their annual interest rate is 6%. And they're making payments every month. So for the record, I haven't explicitly stated this, just in case. The structure we're assuming for annuities is that your payments match how often interest gets compounded. I didn't specify that earlier, but the formula takes it for granted, so it's okay. So those are the given bits of information that we have, and we also know that we have 3 years, so that's our T value in terms of what we're getting ready to do next. So because we need our interest rate. So we have 0.06. We divide that guy by 12. That's going to be 0.005. So again, make sure 2 zeros there. And our number of payments, we have 12 months in a year, and they're wanting to do this in 3 years. So that's 36 total payments. Sorry. It's not 12 times 36. My bad. 12 times 3, which equals 36. That has the added benefit of being correct. So now we've got our I, we've got our N, and we have S. So now 40,000 is our S. We don't know R, but we can fill in all of the stuff in our brackets for our future value formula. So 1 plus I is 1.005 to the 36th power. We subtract 1, close up the numerator parentheses. Underneath, we just have I. All right, so this looks a little more complicated, but it turns out it's not all that bad, because we can work all of this stuff out. This is really just at the moment a gross-looking number. So you can pop all that into your calculator or do it in easy stages, whatever. We can get a number for these brackets. I actually got approximately 39.3361. I'm not actually going to round. I didn't do it in my calculation, but the idea is now we have a number times the unknown we want. We can algebra 1 that and get R by itself via division. So I should call this a twiddly equals, because again, this is not the exact number this works out to be. I'm very careful in general about that. And as I said, I didn't actually round this in my calculator. I just don't feel like writing out 12 decimal places worth of numbers here when I don't have a lot of markers or board space to maneuver. So we've got that guy. 40 grand divided by this 39 point stuff. When I worked that out, that was 1,016 and 88 cents. So they need to put away a little more than $1,000 a month. So that's that. All right. It turns out this actually has a lot to do with the next example, because this is an instance of what you might call a sinking fund. We're putting money away now in order to use it at some point in the future. So in a lot of corporate senses, they'll start doing this when they know when a company knows it's going to incur a debt of some sort. So they'll start putting money aside to go ahead and pay it off, when it comes up. So let's take a look at a sinking fund. Well, we technically just did, but let's take a look at another sinking fund. So yeah, that blank sitting on the file is sinking fund, in case the example sitting underneath it that immediately uses new terminology doesn't get blank. All right, so in this case, we're really dealing with the same problem. We know that they're going to end up building up a $750,000 debt of some sort. So $750,000 is what we have to have set aside, and we've got a T value of 8 years, and they're making semi-annual payments, so that's twice a year. So M is 2, and the interest rate they're getting on their investment is 12%. So that's all of our given information. Then, as we do, not 0.0, 0.12, divided by 2 is 0.06, so our periodic rate is 0.06. 8 years times 2 payments a year, 16 total payments. That's our end. All right, now we're in the exact same boat that we just were. So we know our future value we're shooting for. We don't know R. We've got 1 plus I, 1.06, to the 16th minus 1. Again, those parentheses up top just to make sure that you're putting in your calculator appropriately. Divided by 0.06 down below. Again, we can arithmetic the heck out of this thing. I got 25.6725. Anyway. So then we divide both sides of our equation by the number we get out of the big brackety thing. And I said I got 25.6725. And that means that our company needs to put aside $29,214.11. 10 cents just won't cut it. We'll be short of it. So that's sinking funds. So we've got a couple of examples of those. Same principle, is just now essentially you're normally trying to figure out what you got to put away instead of what you're going to end up with when it's all said and done. All right, now let's get back to Kate. Dang it, Kate. Anyway, so Kate's situation is a little bit different than what we've seen so far. So we know how much Kate's putting away. $500 a quarter. I just about said month. It says quarter. We also know how much she's trying to shoot for. We know both the R and the future value. So this looks a little bit different. Her interest rate, the little r, is 0.08 because it says 8%. Like I said, she's doing this quarterly. So, yeah. Technically, we only need this for one thing, because what we're after now is how long it's going to take her to save up this money. So we actually want the number of payments she's going to have to make in order to hit this threshold, which is where things get kind of complicated. So, as is usual, we're going to take our value for I, the 0.08, divide it by 4. So her periodic rate is 0.02. We don't calculate in here because that's what we're after. So we start filling in our blanks. Well, we know S, 35,000. That's 500. Stuff in brackets. 1.02 to the N minus 1. Okay. So here's where it gets a little technical. Our unknown is sitting up in an exponent. Your chapter 5 sensors may be going off at this point, like needle log, we'll get there. Before we do that, though, remember, we've got to get this exponential piece by itself. So we need to divide both sides by 500. So that goes away. We've got a division by 0.02. So that goes away. Anything we're doing to one side, we have to do to the other. Okay. So here we are at this point. God, I'm getting addicted to jump cuts. I've had no real reason for doing that. I am so sorry. We work out the arithmetic here. This gives me 1.4 on that side when I do this, because we get 70 when we divide 35,000 by 500. Multiplying by 0.02 drops me at 1.4. And we got to get the exponential by itself. Plus 1. Those go poof. Plus 1 on that side. That's 2.4 equals 1.02 to the n. Here's where I'm meant to do the jump cut. All right. So after we've gotten the exponential by itself, we have 2.4 equals 1.02 to the n. Like we saw in chapter 5, to get n out of that exponent, we're going to have to take a logarithm and then hop it out front. So I'm going to use natural logarithms. Base 10s would work as well. So we have ln 2.4, ln 1.02. Technically, the n starts in here. Our properties of logarithms, though, say we can haul him out front like that. And now we just need to get n by itself via division. So we've got ln of 2.4 divided by ln of 1.02. When I worked that out, I got 44.2 as my number if I round to the nearest tenth. It is important to point out here, what are our units in this instance? These are payments. That's what n's being measured in. So we have 44.2 quarters. Human beings might prefer to see that listed as a number of years. Do that for me in an assignment, and then we're going to take a look at a different type of annuity in our next examples.